and to pass you require 33 marks. That is also one kind of calculation. Okay, I don't know which one you are doing, but what I want to say is if time is less, productivity is more. That is the reason we want to make the things as arrange. That is the reason we want to short our items so that time taken to access is very, very small. Yes or no? Are you guys getting why we require shorting? Everyone understood or not? So I will just take the snip of it and I'll keep it for you. So I just copy it and paste it here. Okay. So what you will get if yeah, if the data is shorted, it is easy to access. Easy to access means less time to access. Understood? That's what we need to short the data. That's what we need to short the data. Okay. So to short the data, we require shorting algorithms. We require shorting algorithms. So now what is shorting algorithms? So shorting algorithm means it is used to short the data. Okay, it is of following type. Some of you have already heard. Yes or no? What is that? You know bubble short. Yes or no? Selection short, insertion short, okay, heap short. All these shorting algorithms will be there. Okay. So when you short, what will you achieve? Okay. After shorting, okay, you guys tell me once you short, after that, what you require? Excess of data? Yes or no? That is what you are doing shorting. Yes or no? Everybody. If you are shorting the data, means the data is arranged systematically. After that, what will you do? You will access the data. So after shorting, we can access the data with the help of searching algorithm. Searching algorithms. Algorithm. Okay, there are following searching algorithms. Okay, what is that? Linear search, binary search. Are you guys getting? So we will start with the first searching algorithms. Then we will start with the shorting algorithms. Okay. Are you guys getting what is today agenda of this grooming? Yes, I hope everybody is clear. Okay. So let us start. Okay. Search. So let us go with the searching algorithms. Searching algorithms. Okay. To search the data from the data structure is called as Searching SER, searching algorithms. The first one is linear search. Just give me a minute. I will be back. Then we will start with the linear search. Yes. Okay, so you guys know array? Yes, array. Yes, we have already discussed array yesterday. Can you guys tell me what do you mean by array? Anybody? At least some two, three words I am expecting from your side. Correct, Vishwa Tej. Yes, perfectly correct. Collection of similar data. Yes, correct, Rushikesh. Others, you guys are behaving like, one movie is there on you called as Gajini. Array is used to stare homogeneous. Yes, correct, Gayatri. Yes, homogeneous. Yes, correct. Avinash, Rushikesh, all people. Okay, so I'll quickly revise you. Yes, correct, Rushikesh. So we'll go with this one. And yeah, yes. Fine. So quickly, I will revise array. So what is an array? Array is a homogeneous collection of elements. Suppose this is one array, okay, and the size is, let's say, 6. Whatever the size is there. So this is like, yeah, is always index will start from 0, 1, 2, 3, 4, 5, and 6. Size will be 7. Index will start from 0 to 6. Values will be there. Let's say 10, 15, 20, 9, 8, 7, 2. Okay. Is this data is sorted? No, it is not sorted. Basic simple question. Forgot about data structure, forgot about Java, forgot about everything. My question is, how will you search 7? Simple question. Leave data structure, leave Java, leave everything. Leave this word also, no problem. But think, if you want to see the 7, what you guys have to do in this array? What you guys will do? Very simple. First, you guys will see what number is there in your brain. You have to search for 7. First, you will check whether the first element in the array is 7 or not. Is it equals to 7? No. Then you will search in the next one. Is it equals to 7? Answer is Then you will search in the third one. Is it equals to 7? Answer is no. 20 is 20, 7 is 7. How will you search this? Next, you will check whether it is equals to 7 or no. For this also big no. Okay. For the index 5, you will check is it is equals to 7? Yes. If you found the element, what will you will tell it is index x. Are you guys getting? Basic it is. One by one check. This pattern of is called as linear. Linear means what? Simple. One by one, one. This is called as linear search. Okay. So what will be the logic? How will you do that? You will check. You will create a loop. Okay. You will create one loop, and you will check whether the element. Let's say this is the key. Okay. I am giving one value, giving one name to the number which I want to found called as key. I will check if my key is equals to a of I. If it is found, I can say element found. This is called as linear search. Yes, once you find the element, you stop doing the things. Simple. Are you guys getting an idea for linear search? It is very simple. You can code also. We are not going the coding. We are not touching the coding part. And because we are learning all over the topics of which you can see whether it's present or not. Anybody having any issue? Yes. Done. Understood. Understood. Yes or no? Okay. You guys are not replying. What you guys are having Mehndi in your hands. Others reply yes or no. Anything. How I understand? Yes. Yes. One, two people is replying. Others are dead. Dead bodies. You are depression people of the society. Ultra. Okay. Definition on that. Linear search means searching the element in the sequential way. You know sequential way, which means one by one. That is what called as linear search. Okay. So linear search. Okay, let me write the algorithm for that. Okay, algorithm is not code. It is step-by-step solution of a code. So what is the algorithm for that? First, okay, First, set the key. What is key? The value you want to find. Okay, or the value to be searched. SEARCH. Yes. After that, start from the index 0 to last index. Then compare the key with the array values one by one. Are you guys getting? This is how you have to go for the linear search, and that is what the explanation. Understood. This is called as linear search. Now the question is, what is the problem with linear search? Okay, so let us discuss that what is the problem with linear search. So let us take one more example. Okay, so let us discuss what is the problem with linear search. Suppose there is one array, okay, and this array is very big. This array is very big. And let's say the index will start from 0, 1, 2, 0, 1, 2, 3, 4, 5, and it will go, let's say, 5,000. This is the last index, 5,000. Okay, and you have some value. Let's say 10, 20, 30, 40, 50, 60, 100, 900, 72, 82, and the last value is, let's say, 5,000. Anything. Okay. Now, what is the problem with linear search? If you start searching the element, okay, the key which you have to find now, the key is 72. What will you do? You will start searching from zero index. You will check, is it there? First index, not there. Second, third, and you will find it at the end. At the end, you will find it. Okay, let's say last end. So, how many times you have to compare? How many times you have to compare? At least like 4,998 times you have to compare the values. And comparison will take lot of time. Comparison will take lot of time. Okay, that is the reason this algorithm will not perform good when last index. Now in your mind there will be one question, sir. What if I start searching from the end, sir? Yes or no? What if I start searching from the end? It will, I found it too. But the problem is you don't know what is stored in the array. Maybe you start from the end and the number which you want to find is present there. Because you cannot access the entire array. You don't know what is there in the array and where is that. Are you guys getting? For example, let's say the index of a library. How many books will be there? Lot books are there. Every book is having book ID. Then how will you search it? Are you guys getting what is the problem? So it is what the problem with the linear search. Now what will be the solution? Solution is called as binary search. So let me take the screenshot of it. So what is the problem with the linear search? If the element, okay, if the element, I will talk if the element that we want to search is present in the last SEARCH, perform worst in that case. So there will be problem of time complexity. So what is the solution? Solution for this problem is binary search. And what is binary search? Now let us discuss what is binary search. Okay, so let us try to understand the binary search first. You understood what is the problem in linear searching? Everyone understood? Okay. Now let us go for the binary search. Just give me a minute. We'll start. Till that, you will go through this one. Yes, so let us start with the binary search. So the first thing that you know about binary search is what? Data should be in ascending or descending form. You know ascending and descending, which means your data should be sorted either in terms of ascending or in terms of descending. So for example, let's say there is an data is there in the array, and let me take it some set. So let's say it is index 0, okay, and this is index 1, 2, 3, 4, 5, 6, 7, 8. Whatever data you want to do it, but it should be in the sorted form. For example, 7, 9, 13, 18, 22, 27, 32, 99, and 100. Yes, this is some array, some address will be there, and it will be stored in the reference variable A. So you can see any data will be there. Now you want to find, let's say, the key will be 99. Key will be 99. 99 is the number you want to find. So what you will do, the first step which you will perform in this binary search is what? Finding the middle. What is the steps you guys will go? You guys will first find the middle. What do you mean by finding the middle? Let us see. So what you will do for middle, you guys will go for indexes. Okay, you guys will go for indexes. You will write 0 plus 8 divided by 2. What is 0? First index. What is 8? Last index. Divide by 2 is the middle of this array. First, you will search in the middle. So this is how you guys can see. This is what the middle, and this is what the value present inside the middle. First, what will you do? You will guys check, is my key, that is 99, is equals to middle. If you find in the middle, if you find in the middle means search completed. But if you will not find in the middle, okay, let's say, just a second, let me make it proper. So if you find, then search completed. If not found, okay, suppose you are not able to get it, then you will compare the value. You will compare the value. What you will compare? You will compare whether it is, the key is less than middle or not. If key is less than middle means you can find the key in this area. Are you guys getting or not? If key is less than middle, okay, then you can find it in area 1. This is what area 1. And if it is not like this, which means if key is greater than middle, then you can find it in area 2. Where area 2? This is what the area 2. Yes or no? You guys can see number of comparison become half. Number of comparison is half now, because you have shorted the list in ascending order previously. You have to give the output in. So what will happen? Number of comparison will be less. Are you guys getting, everybody? This is what called as binary search. Yes. So I will just cut it and I'll paste it in your notes. Okay. Yeah, am I audible, Avinash? Okay. You guys understood binary search, or shall I repeat it? Binary search. Everybody understood, or shall I repeat it one more time? Okay, I'll repeat it one more time. Not a problem. Okay, my concern is very simple. Okay, I want you to understood the algorithm. That's it. I'll do it. First, I'll just copy and paste this code here. Not a issue. I will explain it one more time. Okay, so I will just take it to the new. Okay, that is what binary search. It is searching algorithm. Okay? Don't get confused. Searching is means finding. Sorting means arranging in a proper order. So after sorting, if you want to find, you can use binary search. And this is sorting algorithm. Okay, and yes. So for that, what is the first thing you should have? Data should be uh, yeah, data should be in ascending order. Think from ascending perspective, data should be in the ascending order. Then what will happen? Suppose you guys are having array. This is your array. Okay. Let me make it proper. Let's say this is one array. Okay. The data you have to insert should be in the ascending order. So let me write the index. It is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 and 16. So let's store one value. Let's say 5, 6, 9, 12, 18, 22, 25, 27, 32, 35, 37. Let's say 43, 47, 98, 100, 102, 105, and 110. You want to search a value. What is the value you want to be searched? Called as key. Your key should be, let's say, 100. Okay, 100 you have to find. Okay, what you guys will do, the first step is you will find out the middle. You have to find out the middle. How will you find the middle? Last index. Okay, that is the first index, and that is what? The last index. So what you guys have to do? First index plus last index divided by 2. 0 plus 16 divided by 2. 16 by 2 divide is 8. This is called as middle of this binary search. First, you will compare with the middle. 32. Is 32 is equals to 100? Answer is no. You have not found the element in the middle. Now, based on the middle, okay, because you guys can see this side it is less than middle, this side it is greater than middle. So, if the number which you want to search is greater than the middle, then you will search in this area. You will search in this area. You will search in this area. And if the number is less than the middle, then you will search in this area. So what will happen? Half searching will be there. Suppose if the number is 100, then you don't have to search in this half of the array. You start searching from 9 and then you will get it. Again, repetitively this algorithm will work. Okay, how it will work? After that, okay, this will be the array. I'll show you just 1 second. Yes. So after this one, what will be the array? The array which you will get is this one. Okay. So I'll just copy it and I will write it here. Step 2. Okay. I will write it here. Step 2. Compare with the middle. Okay. So let me compare with the middle. I will write all those things. Don't worry. Compare with the middle. Okay. You will compare with the middle means you will get the this array now. Oh, what it is. You will get this array. Now again what you guys have to do in this array, you guys have to again find the middle. Okay, remember what is the element? Element is the key which you have to find is 100. So again, what you will do, try to find the middle. So how will you find the middle? You will find the middle by adding 8 plus 16 by 24 by 2 is equals to 12. Here is the middle. Here is the middle. Again compare it with the middle. Whether the number 100 is less than or greater than middle. If it is less than, you can find it in this area. If it is greater than, you can find in this area. So after that we get to know we have to find our array, our number into this area. Then again there will be this list, okay, and you will use that array also. So you will use it here. Let's say step 3 here. Step 3. Again you will do the same thing. Again you will find the middle. Now this time how will you find the middle? 13 plus 16 is equals to divide by 2. 6, 7, 8, 9, 29 divided by 2. How much it is? 1 for 14. Okay. You can consider 14 roughly. So 14 is the middle. What is 14? 14 is the middle. Again, what will you do? Compare your key with the middle. Check what is that? Is 100 is equals to 102? Answer is no. Then check which direction you have to go, left or right. So after that you realize your key is small. Key is small means you will go into the left side. Now go to, this is what the middle, and we'll go to the left side. Then left will be, now what will be the array we will get? 100. The array which we'll get is 100. Again we will find middle, and this time you will see 100 is equals to 100 element found. So again continuously this will go step by step. Are you guys getting? This is how binary search work. Understood now? I hope you are getting a proper idea of it. Yes, everyone understood. So I will write it here. Step by step working of binary search. So I will just cut and paste all the steps here properly. So just give me a minute. I'll just arrange the data. Okay, I'll copy it and I'll paste it. Okay. Then I require step 2. Then again I will go to this tool and I will snip it. Next step 2. Okay. Again the step 2 will be there. So that is what the step 2. Step 2, after that step 3. And that is what the step 3 is. And what we will do, we will write the algorithm for that. So algorithm for binary search. So let's say the first one. Use the data in ascending order. Okay. After that, what you will do? Find the middle. Find the middle of the array. Okay. sorry, use the data in ascending order and set the key. Key means, you know what is that? The value which you want to search. Okay, set the key. Find the middle of the array. How will you find the middle of array? You can find the middle of array by first index. Okay, I will write it here. Middle is equals to first index plus last index. Everything is divided by divided by 2. After that, compare the element with the middle. If key found, stop the algorithm. Algorithm. Yes. If not, compare the key with the middle. So what will you write? Okay, you will write, for example, what will you write? You will write if the key should be equals to a of middle. Okay, then what will you do? You will say, sorry, you compare it first. You will say if key is less than a middle, which means you will get the element in which area? Area 1. Left side is area 1. If not, then you will find the area. Area 2 means area that is next to the middle. Okay. And what is that? Repeat the algorithms, repeat the step from 2 to 6 until you find key. If key is not there, suppose you are finding something which is not there, okay, like your carrier, yes. So if key not found, then stop the algorithm. I hope you guys are clear with the searching algorithms. Yes. Yes or no? Just read it once. Okay, read it once. I will be back in a minute. Okay, read it once. Everybody. Okay, now let us go for the next topic. That is what shorting algorithms. Okay, shorting algorithms. So, what is that shorting algorithms? So, to short the data into ascending or ascending or descending fashion is done with the help of shorting algorithms. Algorithms. Yeah. The first shorting algorithm that we are gonna learn is called as bubble short. Okay, it's wonderful algorithm called as bubble short. Okay, what is going on? Oh, oh, oh. So let us start with the bubble short. Is my yes? Okay, we'll go with the bubble short. So I'm just increasing the size of this one. It is very simple. It is very simple. I'll tell you what is that bubble short algorithm. So for that, let me take some numbers. Okay, so I'll take one array which we want to short. Okay, I'll explain you algorithm step by step. So let's say there is one array 7, 8, 9, 2, 2, 1, and 6. This I want to short. Okay, you know the output. What is the output? 1, 2, 6, 7, 8, 9. Correct? So the first algorithm that we are learning is short. So what will happen in this bubble short? We will pass the bubble. We will pass the bubble, also called as pass. Now, what do you mean by passing the bubble? So, first step, you will do the first pass. Let's say pass 1. What you will do in the pass 1? You guys will compare these two numbers. Okay, let's say assume it is an array and the index will be 0, 1, 2, 3, 4, 5. What you guys will do, you will compare, and the name of this array is what you'll compare. You'll compare this 7 and 8, and you will do what if 7 is greater than 8. If this condition is true, okay, if this condition is true means what, this number is big, then what will you do? You guys will swap these two numbers. Yes, you guys will swap this two number when this condition is false. If it is true, okay, I'll tell you in very simple way, don't get confused. So I will just remove this one. Okay, just a second. This and I'll fill it with black. So what I want to say is what you guys can do, that you guys can compare. Okay, how will you compare? You will say a of 0 is greater than a of 1. You can see this is 0, this is 1. If a of 0 is greater than a of 1, then what will you do? You will swap the value. Swap means you will change the value a1 to a0, a0 to a1. Now let us use this one. Is 7 is greater than 8? Answer is false. If it is false, we will not do anything. If it is true, we will swap it. Are you guys getting? If this comparison is true, we swap the values. If the comparison is false, we will do nothing. So first pass, this value will be like that. So no swap will be there. After that, what you will do, you will compare the next two values. So here 7, okay, and I will write 8, 9, 2, 1, 6. Now this time you will compare these two values using the same formula. What is that? Using the same concept, that is a of 0 is equals to a of 1. Now you will increment the value of a. Now this is a of 1, a of 2. So you will compare 1 and 2. Okay, and you will compare 8 is greater than 9. True or false? True or false? It is false. If it is false, do I swap the value? Tell me, should I swap the values? No, we will not swap the values. Okay, then what we will do next? We will compare next two set of values. This is 1, this is 6. Now this time we will compare 9 and 2. Yes, now what we will do, we will compare these two values. Okay, so can you tell me what is the comparison? 9 is greater than 2. Correct? What do you think? True or false? This time condition is true or false? True. If true means swipe. So what will you do? You will swipe these two numbers. You will swipe this two numbers. Now what will be this one? 7, 8, 2, 9, 1 and 6. Now what will you do? Again you will compare these two numbers. Yes, 9 greater than 1. What do you think? True or false? True or false? It is true. True means swap. Again you will swap it. 9 this side, 1 that side. So your algorithm will be like, yes. So it will be like 7, 8, 2, 1, 9, 6. Now you will compare this last two. Again 9 is greater than 6. True or false? True. Again swipe it. What will you swipe? You will swipe these two values. You will swipe these two values 9 and 6. And after my pass 1, what will you get? You will get 2, 1, 6 and 9. This is what? Only the first pass. In the first pass, what will you get? You will get, what you will get? You will get highest value or maximum value at its position. Highest value at its position. You can see 9 is the highest and it will set in the end of this array. Are you guys getting? This is called as pass 1. Now what we will do? We will go for the second pass. Yes. Now we will go for the second pass. First pass complete, we will go for the second pass. Now I have one array. You guys can see this is my final array, and I have to compare till this point because 9 gets its position. So again, what will be the array? Array will be 7, 8, 2, 1, 6, and 9. Okay, pass 2. Again, same thing you have to do repeatedly. You will compare this 2. Is 7 is greater than 8? If it is true, means swipe. If false, means skip. So it is true or false? It is false. It will be like that. Then again you will compare this to. You will compare this to. What will be that? Is 8 is greater than 2? Yes, true. True means swap. So you will put 2 here, 8 here. Now your list will be like 7, 2, 8, 1, 6, 9. Yes. Now you will compare the next two numbers, that is 8 and 1. Again 8 is greater than 1. If true means swipe. Swap, sorry. Yes, it is condition is true. This number will go there. This will come here. So it will be 7, 2, 1, 8, 6, 9. Again, you will compare these two numbers. What will be the output? Output will be true. True means swipe it. So your list will be 7, 2, 1, 8, 6, 9. Sorry, 7, 2, 1, 6, 8, 9. So it is 7, 2, 1, 6, 8, 9. You can see second largest element got the position. This is in the pass 2. Are you guys getting? Now what is the list you guys will have? Only this one. These two are sorted. You can see 8, 9 is sorted. After that, what will you do? You will go for the third pass. Okay, we will take your third pass here, 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 yeah. So that will be your third pass. I will write it here. In your third pass, what will be the output you guys are having? You are having 721689. Okay, you are having what in the third pass? You are having the value 721689. This 2 is done. In the second pass, second value get the highest position. Now we will go for the next one. Next third pass. Again you will compare this two. 7 is greater than 2. If answer is true means swap. So it will get swept like this, and this will become 7, sorry, 2, 7, 1, 6, 8, 9. This 2, leave this 2 now. Next comparison. 7 and 1. If 7 is greater than 1, true or false? True. True means swap. 7 will go there, 1 will come there. It will become 2, 1, 7, 6, 8, 9. Third, it will compare 7 greater than 6. Again, answer will be true. True means swap. 7 will come there, 8 will come there. What it will become? 2, 1, 6, 7, 8, 9. You can see the third element got the position in the third pass. Now it will be pass 4. Okay, so it will be, let's say, pass 4. So I will make pass 4 here. I will just color it to the black, and we are ready to go. Pass 4. Now what is there in the pass 4? Okay, you guys can see we are having the value 216789. Okay, 216789, and 9. You guys can see this 3 is already set. Now you have to compare again these two numbers. You have to compare this and this. If it is true means swap. If it is false means skip. So since it is true, you guys have to swap it there and there. It will become 1, 2, 6, 7, 8, and 9. You will compare this two. Again, you guys know that already these three are sorted. So it will be 2 greater than 6. Is it true? No, it is false. Means don't swap. Done. Again, it will go to this. 6 greater than 7. False. 7 greater than 8. False. 8 greater than 9. False. No swap. So the final value that you will get is 1, 2, 6, 7, 8, 9. This is the final answer, and you guys can see it is shorted. This algorithm is called as bubble sort. Yes, getting, just go through it one more time. Okay, take a minute and just go through all the step. So this is pass one. Okay, I want you to write and go through step by step. Okay, I'll give you 5 minutes of time to go through it. So everybody, open your rough note and start doing the bubble shot. How many passes are there? Okay, so there will be always n minus 1 pass. If you write code for that, okay, we are not going for the coding part, Tejashwini, but if you go for the coding part, if the number of element is 6, total number of passes will be n minus 1, that is 5, where n is the number of values. Getting? General. Okay, I'll give you 2 minutes. Everybody go for it, go for it. Yes, done. Okay, so I will just take the screenshot and I'll upload it. Just a second. Yes, so I will write some point for bubble shot. So bubble shot is a shorting algorithm. We have to pass bubble number of pass is equals to n minus 1, where n is what? Number of n is number of element. Okay, so this is what bubble chart. You will write the algorithm for that. So algorithm for bubble short. So what is the first step? Compare the two elements. Okay, let's say a of 0 and we will say let a of left. Okay, we will consider and initialize left and right. So what we'll do, we will initialize left by 0 and right by last index minus 1. Just I am writing the number so that we can increment or decrement it. We will compare a of left is greater than a of right. What you will do? Swap the element, correct? If true. Okay, if this comparison if true, then swap the element. If false, if false, don't swap. Continue till the end. Okay. Immediately after that, what will you do? Increment the left and it's left plus 1. Just algorithm it is nothing. What I have done, I'm writing, try to write in the words, increment the okay. Number of paths will be depend on the number of element. And here is the step by step. I write it here. Step by step diagram. Explanation. Okay. I hope you guys are understanding this one. Okay. And now let us go for the next algorithm called as selection sort. What is selection sort? Let us try to understand. So let me open the paint here. Is my screen visible to everyone? Is it visible to everyone? Yes or no? Okay. Now let us go for the next selection shot. Okay. Selection shot. What is selection shot? So for that again we require one numbers to be shorted. So let us take 5, 2, 1, 7 and 9. So what you guys have to do in the selection short is you guys have to consider this number as minimum number. What you guys have to do is you will select the number minimum, you will consider this is the minimum number, and then you start comparing the number with the remaining number. Okay, if it is minimum, okay, then replace the number. If it is minimum is true, then what will you do? Replace the, for example, okay, you will consider, let's say min is equals to 5. You will compare, is 2 is less than 5? Answer is yes. Yes or no? Is 2 is less than 5? Answer is true. If it is true, update your min variable. So we'll update this min by 2. Now compare this one. 1 is less than 2. Yes. Then again replace this min by 1. Again compare it with 7. Is 1 is less than 7? Sorry, is 1 is like this? 1 is the minimum? No. 9 is the minimum? No. So we get the number 1 as the minimum. Once you get the number as minimum, swipe the number with the original number. So it will be like 1, 2, 5, 7, 9. Okay. Again do this in this one. So you will consider this as minimum and try to compare it. Is 5 is minimum than 2? No. Is 7 is minimum than 2? No. Is 9 is minimum than 2? No. Done. Third pass. You will compare 1, 2, and you will see these three numbers you will do. You will consider this as minimum and then compare. So what you do, minimum number is 5 and you start comparing. You compare this 7 with this 5. Is it minimum? No. If you compare this one with 5, answer is no. Then the remaining answer will be 1, 2, 5, 7, 9. And you guys can see this is shorted. Okay. I'll take one more example. So just coloring. I'll take one more example. Observe it carefully. So I will take some numbers like yes, okay, 7, 5, 4, 9, 11, 2, and 1. Very simple. What I'll do, I will consider this as minimum. Okay, my minimum is 7, and I will compare from the remaining list. 5 is less than 7. No. Yes, 5 is less than 7. Yes. If you found answer is yes, update this one by 5. Then you will compare in this one. Next element is 4. Yes, 4 is also minimum. 9, no. 11, no. 2, yes. 1, yes. Minimum number you will find is 1. Now what will you do? You will interchange the number from minimum. So what it will become? It will become 1, 5, 4, 9, 11, 2, and 7. Now you will start doing from this list. You will consider this as minimum and you start comparing. Minimum is equals to 5. Okay, this is 4 is minimum than 5. Yes, make it 4. 9, no. 11, no. 2, yes. 7, no. So out of that you will found 2 is the minimum. What will you do? Interchange this 2 with this one. Now your array will be 1, 2, 3, 4, 5, 6, 7, 11, 5, 7. Then you will go for this third one. You will consider this 4 as minimum and you start comparing. 9 less than minimum, no. 11 less than minimum, no. 5 no. 7 less than minimum, no. No swapping will be there. Then you have to compare only which direction. Only in this array you have to compare. So 1, 2, 4, 9, 11, 5, and 7. Now in this time you will consider this is 9 and you compare. Is 11 is less than this one? No. Is 5 is less than this one? Yes. Is 7 is less than this one? No. Then you change 5 and 9. Okay, you change 5 and 9, then what will be the output? Output will be 1, 2, 4, 5, 11, 9, and 7. And then you will compare in this 3 1. You will consider 11 as minimum and you will compare 9 and 7. What you will get? 7. You will change the 7 and 9. And the final answer is 17911. And you guys can see this is shorted. This is called as selection short. Are you guys getting? So I will write the points here. Okay, I will just take the screenshot of all this and keep it in the notes. So I will write the algorithm for that. So algorithm for selection short. Define the element, define the minimum element. Then start comparing with the remaining n minus 1 element. Find element one second with the remaining n minus 1 elements. if you found if found a number less than the minimum, then what will you do? Update the minimum. And travels means just access travels to the end of the array. Then if found less than, swap that number with the minimum. Swap that number with the minimum. If not found, ignore. Yes, understanding. So very simple. Start comparing one by one, and if you find minimum, okay, and then okay, one more point, and then start the and okay again repeat the steps for remaining n minus one element. Every time one element will get the position. One if six is there, five will there, then four will be there, then two will be there, and this algorithm will get terminated. Understood? Okay, so this is what called as selection shot. Okay, now what I will do, so I will give you some questions and you have to do like this. So today assignment I will give. Today assignment, okay. So try to short the list by using bubble shot and selection shot. What you guys can do, you guys can go for your notebook, you guys can write down, and this you have to upload. Where to upload, I'll tell you. So I will give you two lists and you have to do it. So first my list is 7, 8, 9, 10, 3, 2, 1, and 11. The second list is, let's say, 9, 8, sorry, 9, 8, 7, 4, 5, this. Okay. This you have to do it. So first you will do it first for bubble shot, then selection shot, then bubble shot, then selection shot. You don't have to write the code like how I have done. Same pattern you have to follow and upload it. Now where to upload it? So you guys can upload the assignment here only. Just give me a second. I'll give you the code for that. Yeah. Yes, so you guys have to upload the assignment in this link. Okay, you have to join something called as Google Classroom. Once you join, you will get a session like this, Sonata software, and there is one something called as classwork. Okay, I'll create one assignment. So let's say assignment for shorting. Okay, and you guys have to upload it. So when you try to upload this one, there will be one option called as turn in. You have to click on the turn in. Okay, I will share this link. I will share this entire file into the Skype groups. Okay, it is mandatory to upload all before yesterday class. Yesterday also we are having grooming session on the remaining algorithms and the patterns. Understood? Is it clear to everyone? Yes, I will upload today notes, Rushikesh. Yes, so I will share this one. Okay, everyone do nobody will leave the session. I'm just uploading this in the Skype group. You guys can first register for this one. Okay, Neha, we will tell you, we will inform you once the date will get scheduled, but you guys start preparing on whatever we are learning. Okay, I want maximum number of people to clear the interview. Understood? So I will upload this all, but don't forget to submit the assignment. If your assignment is not submitted today, means it's not good for you. So submit all the assignment. Okay, I will save it here. This one as day 3. Okay. It's not day 3, it's day 4 actually. Okay, it's day 3 and this is what? Sorting and searching. Okay, I will save it in my desktop and I will upload it. Understood? Everyone, any doubt? If you have any doubt, you can come to branch and you can ask me. But assignment has to be uploaded like how I have done for this one. Yes, I will upload this all into the Skype groups. Okay. Okay, so I'll give you 5 minutes of time. Everyone just go through these things. Okay. If you have any doubt, you can ask. 5 minutes time I'll give you. Read this entire documentation. Assignment is in written form. Yes, you can do it neatly on your notebook and you can click the picture and you can upload it. Okay, no nothing fancy thing, no upload, no type, no nothing. Just usually how you are doing in your notebook, you do it. Just click a photo and upload it. Understanding? Yes. Go through all the things one by one. Okay, go through it. Okay, so last day of submitting the assignment is before tomorrow class. Again, tomorrow there will be session at the same time, and we will go for the remaining algorithms. That is insertion sort and heap sort. Okay, so for heap sort, just go through the binary tree which we have discussed yesterday, and come to tomorrow session. Okay, without fail. If you miss the class without any reason, then things won't be good. Okay, I hope I'm clear to everyone. Yes. I will share this document to your Skype groups. You guys can go through this. If you guys click on that link, you guys will be joining the Google Classroom. Okay, there you have to upload the assignment. Understood? Puja, Virajdar Puja. Yes. Okay, so yes, that's all about today's session. You guys can leave the session. We'll see you tomorrow at same time, 11:15 sharp. Okay, thank you.